Hi, hello, welcome back to our channel. Today we are going to discuss about the short answer questions from the thermodynamics. It is very important chapter for both TS and AP boards. And in this first S.A.Q is what is the first law of thermodynamics? What is the first law of thermodynamics? Look here, we are taking one system and we are providing heat energy to the system. Heat energy is represented by dq. dq means we are changing the heat energy. You can take the example of our stove, and we are providing the heat energy to the system, one bowl. Then what happens? It is utilized into two ways. One part is utilized to increase the internal energy and remaining part is to do some work. Just you should imagine that one bowl is there on the stove, we are providing the heat energy. So here it is utilized into two ways. One is what? To increase the internal energy. A part of the energy is to increase the internal energy. Remaining part is to do mechanical work. So this mechanical work we can express in terms of pressure into change in volume. One more formula for work done is the pressure into change in volume. Then how to write the first law of thermodynamics? dq equals to du plus dw. Now dq equals to du plus pressure into change in volume. So when we are writing the statement of first law of thermodynamics, what is that? When you provide the heat energy to the system, it is utilized into two ways. A part of the energy is to increase the internal energy, remaining part is to do some mechanical work. That is called the first law of thermodynamics. But here sign convention is also very important. What is that? See, work done on the system, is negative. Like that, work done by the system is positive. dq is giving to the system is positive. dq is means heat energy is taking from the system is negative. If the internal energy is increases, that is positive. If internal energy is decreasing, that is the negative. And what are the limitations of first law of thermodynamics? It didn't explain what is the direction of the heat energy. And one more time, you remember that what is that sign convention? Work done on the system. Just you are pressing that piston on the container. That is the negative. Work done by the system, that is positive. If du is increases, that is what? Positive. If du is decreases, that is the negative. Second short answer is what? Define the principles of specific heats. How many types of specific heats are there? At constant pressure it is represented by Cp, and at constant volume it is represented by Cv. So generally, what is the specific heat? The amount of heat energy required to provide the temperature of 1 degree centigrade. How much energy is required per unit mass? That is called what? Specific heat. General formula for specific heat is S equals to 1 by m into dq by dt. So amount of heat energy required to raise the temperature of 1 unit degree, either Kelvin or centigrade, of 1 unit mass. This board is there. We want to increase only 1 kg of this one, or 1 meter cube. Any 1 unit you are taking, how much heat energy is required? That is called the specific heat. But specific heats are two types. One is the Cp, another one is the Cv. The question is here, first we should define what is the Cp and what is the Cv. This is the general specific heat. Cp means the amount of heat energy required to raise the temperature of the system through 1 degree centigrade at constant pressure. That is called the Cp. Like that, we are doing same thing at constant volume. That is called the Cv. Then how to write the expressions for Cp and Cv? Look here. Instead of S, we are taking specific heat at constant pressure, but we are expressing in terms of moles. The amount of heat energy required to raise the temperature of 1 degree centigrade of 1 mole of the gas is called the, at constant temperature, is called the specific heat at constant pressure. Like that, what is the specific heat at constant volume? Same expression, but we are doing at constant volume, dq by dt at constant volume. So these are the definitions are over. Then one more part is there in this. Why Cp is greater than Cv? Just now we discussed about what is the first law of thermodynamics. See, dq equals to du plus pressure into change in volume. If at constant volume means immediately change in volume equals to how much? 0. So dq equals to du. So at constant volume, whatever we are providing the heat energy, that is utilized to increase the internal energy. Then come to our next point. At constant pressure, dq equals to two things it is doing. One is to increase the internal energy, then to do some mechanical work. See, this is at constant volume and this is at constant pressure. Look here, the person who is doing two works, we require the more energy. Like that, the person who is doing single work, the person requires the less energy. Just we can imagine and we can apply here. Then easily you can understand why Cp is greater than Cv. Look here, second expression. At constant pressure, heat energy is utilized into two ways. To increase the internal energy, to do some mechanical work. But at constant volume, this part becomes to 0. The entire heat energy is to increase the internal energy. So always where we should provide the more heat energy? At constant pressure. So Cp is greater than Cv. Then our third short answer question is very important it is. That is, we give the relation between Cp and Cv. Cp is the specific heat at constant pressure and Cv is the specific heat at constant volume. Just now we know that what are the definitions also. Look here. Our third question is relation between them. Simply we can call Cp minus Cv is equals to universal gas constant. Look, from first law of thermodynamics, we know that dq equals to du plus dw. Otherwise we are writing pressure into change in volume. So first we are taking at constant volume, we know that change in volume is equals to 0, dv equals to 0. So dq at constant volume we can write it du. But instead of dq, just now we know that dq at constant volume, what we are writing? 1 by n into Cv equals to 1 by n into dq by dt. From this dqv, what we are writing? N into Cv into dt is nothing but internal energy. This is equation number 1. Like that same thing at constant pressure. At constant pressure, what we are writing? dq equals to du plus pressure into change in volume. But instead of dq, this is at constant pressure, what we are writing? Cp equals to 1 by n into dq at constant pressure by dt. If we are taking at constant pressure, we can write it Ncp dt equals to du plus pressure into change in volume. So try to understand here, there is no work done, that's why this term becomes to 0. But here work done is there, that's why we are getting same expression. This is equation number 1 and 2. Look here, this is 1 and this is 2. And instead of du, look here, instead of du, what we are writing? Ncv dt. Substitute in this. All expressions only in this. Ncp dt. Instead of du, Ncv dt plus pressure into change in volume. How to write this expression now? When it comes this side, n dt is the common, within brackets we are getting Cp minus Cv. RHS side only PdV is there. Now you know that ideal gas equation PV equals to nRT. At constant pressure, so second part is at constant pressure. When you are differentiating this equation, pressure is constant, differentiation of V is the dV. N is constant, R is constant, differentiation of temperature is the dt. So look here, this is pressure into change in volume, we can write it nR into dt. So instead of PdV we are writing now nR dt, which is cancelled, Nn cancelled, dt cancelled. Finally, we are getting Cp minus Cv equals to R. This is the relation between specific heat at constant pressure and specific heat at constant volume. Fourth short answer is, what is the work done during isothermal process? You know that there are 4 types of thermodynamic process. What are those? Isothermal, adiabatic, isochoric and isobaric. First of all, this belongs to isothermal, means the system is going from one state to the another state at constant temperature. So entire process, if the temperature is constant, that is called which process? Isothermal process. But in this answer, we have to find out the what is the work done. Look, here all gases are obeying the Boyle's law. PV equals to constant. When T is constant, at constant temperature, pressure is inversely proportional to the volume. So this is called which law? Boyle's law. Just you should consider one cylinder is there and one piston is there. It is having how many number of moles gas is there? N is there, and pressure is the P, and change in volume. Here we can take it change in volume. We remember that when we are finding the change in pressure, volume is constant. When we are considering the volume is changing, means pressure is constant. In that entire experiment, which is constant, temperature is the constant. So how much, suppose this is moving from here to here, how much work is done? The change in volume is a dV. We can express that work done equals to dW equals to pressure into change in volume. But now we can find out the total work done to move, that is from initial volume V1 to V2. So both the sides we can take it integration. Both the sides take integration. So integration of dW equals to integration of pressure into change in volume. But initial volume is the V1, final volume is the V2. Here integration differentiation is cancelled, and you know that from ideal gas PV equals to nRT. Then instead of P, what we are writing? nRT by V. So W equals to, instead of P we are writing nRT by V into dV. The limitations are V1 to V2. Here nRT is constant. So work done equals to nRT. You remember that integration of 1 by V into dV formula is log E V. E is the base. This is the formula. So nRT, integration of 1 by dV is, we are writing log E V. But here limitations are there. Lower limit, starting position is V1 and the final volume is how much? V2. So we should write here work done equals to nRT. First we can apply the upper limit. Instead of V we are writing V2 minus then lower limit log E V1. But you know in 10th class, instead of log A minus B we are writing log A by B also. So work done equals to nRT log E V2 by V1. If in terms of base 10 also we can express this one. nRT we are getting 2.303 nRT. Instead of E we are taking base 10 log 10 V2 by V1. So this is the work done during the isothermal process. Isothermal process means the system is going from one state to the another state at constant temperature. Here all gases are obeying the Boyle's law. It is very, very important. Just we can remember that work done we can take it in terms of pressure into change in volume. Then instead of P we are substituting nRT by V. And you remember that integration formula 1 by V into dV is the log E V. Fifth short answer question is, we can discuss the work done in adiabatic process. So what is the adiabatic process? The system is going from one state to the another state at constant heat energy. Here all gases are obeying this one. PV power gamma equals to constant. So here P belongs to pressure, V belongs to volume, gamma is the ratio of specific heats. Gamma equals to Cp by Cv. Then it should be right P1 V1 power gamma equals to P2 V2 power gamma equals to constant. This also we can write it. Then come to our answer. Here we can take it same, work done equals to pressure into change in volume. Both the sides we are taking the integration. Integration of dW equals to integration of VdV. The limitations are V1 to V2. So here this one cancel, work done equals to integration of V1 to V2. Instead of P, what we are writing? K by V power gamma into dV. K is the constant and we should remember that, see, integration of 1 by V power gamma, we are writing V power minus gamma into dV. This formula is V power minus gamma plus 1 by minus gamma plus 1. So here space is not sufficient, that's why I am writing here. See, now we are taking work done equals to K is constant. Integration of 1 by V power gamma, just now what I said, that formula is V power 1 minus gamma by 1 minus gamma. As usual, limitations are V1 and V2. Wherever that V is there, first we should apply the upper limit minus lower limit. So K by 1 minus gamma into upper limit is V2 power 1 minus gamma minus V1 power 1 minus gamma. Now how to write this expression? Work done equals to 1 by 1 minus gamma. Here K is there, no? K is I am sending inside. So you can get it K into V2 power 1 minus gamma minus K into V1 power 1 minus gamma. Now come to this 1 by 1 minus gamma. Instead of K, here V2 is there, I am taking this expression P2 V2 power gamma. Then instead of V2 power 1 minus gamma, we can write it V2 power 1, V2 power minus gamma. Try to understand, I have splitted V2 power 1 into V2 power minus gamma. Instead of K, I have taken P2 V2 power gamma minus, here I am taking P1 V1 power gamma, here V1 power 1, V1 power minus gamma. Then work done equals to 1 by 1 minus gamma. Look at this expression here, minus gamma, this one, V2 power 0 is 1. So we can get here P2 V2 minus P1 V1. P1 V1. Instead of that we are taking 0. Then we know that from ideal gas equation, what is that? PV equals to nRT. PV equals to nRT. So we can take it 1 by 1 minus gamma. Instead of P2 V2, I am taking nRT2 minus nRT1, which is common here. nR by 1 minus gamma equals to T2 minus T1. This is the work done in adiabatic process. Little bit difficult comparing with the isothermal process. The main thing we should remember here, P1 V1 power gases are obeying this one and we should take this one. We can remember integration of V power minus gamma into dV formula is this one. We should by heart because in second year MPC only we are getting the integrations. By BC people try to understand this one. Then substitute all this. We can get the final expression for the work done is nR by 1 minus gamma into T2 minus T1. Sixth question is write the difference between the isothermal process and adiabatic process. In previous questions only we know the clarity what is isothermal process. In this it is very slow process. Adiabatic process side we should write it is the quick process. Here isothermal side it is temperature is constant and that side heat energy is constant. Here the temperature is exchanging between the system and surroundings. But isothermal side what we are, adiabatic process side what we are saying, there is no exchange of the heat energy. And here good conducting material we are using, but here bad conductors, inside the bad conductor we are doing this one. And isothermal side what we are saying, all gases are obeying PV equals to constant Boyle's law. And adiabatic side PV power gamma equals to constant. It's very simple answer. Try to understand this one. Then our seventh question is what is cyclic and non-cyclic process. If the process is going to the different stages and coming back to the original position, that is called the cyclic process. Suppose ice is there. Ice becomes to water. water becomes to steam, then steam becomes to water, then water becomes to ice. So based on the providing the heat energy, we can observe the cyclic process, the process which is retraced back, that is called the reversible process. But here it is going into different stages and coming back to the original state, that is called the cyclic process. Then what is a non-cyclic process? We can't, it is not coming to the original position, that is called the non-cyclic process. Then what is the quasi-static process? So it is very simple. It is infinitesimally slow process. Here always the system is in thermal and mechanical equilibrium with the surroundings. When we are doing slowly this one, it is adjusting with surroundings, it is maintaining constant volume, constant pressure, constant temperature, then constant heat energy. So we can say thermal and mechanical equilibrium with the surroundings, and that too it is infinitesimally slow process, that is called the quasi-static process. So these are the short answer questions from the thermodynamics. Try to understand this one. In the previous classes I have given that motion in a straight line, motion in a plane, short answers also. If you want, you can refer my previous videos, and if any inter students are required, please forward it. Thank you. Please subscribe my channel.